Hello everyone, my name is Saeid Hoseinipour. I recently received PhD degree in data science from Amirkabir University, Tehran Polytechnic in Iran. I'm also honored to have been nominated for Best Researcher Award of International Research Award on Statistical Methods for analyzing engineering data. I want to thank Science Father for giving me this opportunity. I would like to thank my co-authors. In this informal presentation, I will explain 5 repository GitHub for 5 articles extracted from my PhD thesis. In contrast to clustering, co-clustering is more effective because it enables the discovery of relation between rows and columns of a dyadic data matrix such as Word document matrix and user movie, user product, product customer, and so on matrix. Most algorithms are based on equivalence distance or Frobenius norm and Kullback Leibers. We propose to apply the orthogonality parameter of control orthogonality by adding 2 regularization to objective function. Lambda for control orthogonality of columns F and mu control orthogonality of columns G. For this new objective function, we can propose OPNMTF algorithm can be implement clustering and co-clustering by probabilistic interpretation. After that, can be used OPNMTF for implement to text dataset. OPNMTF algorithm can be used for polysemions word identification. The concept polysemions is commonly used to define words that might have multiple meanings in different contexts. Document cluster 1 and word cluster 1 and DC2, WC2, DC3 and WC3 can contain words representing topic medical, information retrieval, and aeronautical systems. In addition, the words in WC1 such as layer and body and theory are suitable for use in document cluster 1 as medical topic and document cluster 3 as a aeronautical system topic. There are 4 highlights for this paper. 1. Our algorithm works by multiplicative update rules and it is convergence. 2. Adding 2 penalties for controlling the orthogonality of row and column clusters. 3. Unifying a class of algorithms for co-clustering based on alpha-divergence. 4. All datasets and algorithm codes are valuable on GitHub as NMTF co-class repository GitHub. NMTF co-class repository GitHub valuable and all material valuable here includes dataset, image, evaluation, models, supplementary material, scientific data, visualization, and a brief of objective function of models, data sets, model, and visualization. In supplementary material section, we consider supplementary material from GitHub and from expert system with application, and valuable personal URL for 50 days free access to the article. Supplementary material for OPNMTF algorithms. We first present scientific dataset, latent block model for Bernoulli, Poisson, and truncate Gaussian. After that, we implement OPNMTF of them and show results. More visualization valuable for some text dataset, web ACE and CSTR dataset with different value for S as number of column clusters. Also for classic tree dataset, we consider different value for S, but in original article just consider S equal 3 and show word clouds for classic tree dataset. All co-clustering algorithms can be formulated as a optimization problem with two different perspectives, similarity and dissimilarity. The objective function of NMTF models is to minimize the divergence between the data matrix and approximation matrix from a dissimilarity perspective. Maximizing the complete log likelihood function from a similarity perspective is the objective function of latent block model. Model-based approach can be used by various distributions for different applications to implement co-clustering. These models do not have a unified framework. Moreover, sparse and high-dimensional data make them difficult to analyze. In this paper, we present a sparse and non-sparse version exponential family latent block model for co-clustering that unify many models with various types of data, include binary, discrete, and continuous. Finally, we compared ELBM and SELBM on some real document word matrices. ELBM co-class repository available on GitHub. All material is here. A brief of models and results and visualization, word clouds for implement the two algorithms. After that, another work about I focus on matrix factorization and probabilistic approach of co-clustering. During research, I discovered some research gap between relation between exponential latent block model and Bergman NMTF for co-clustering, and present one equivalence between exponential family latent block model and Bergman NMTF co-clustering. Hybrid co-clustering repository available. All material is here. A brief of objective function and site evaluation reference, and the two last repository about two different objective function for implement on Persian dataset with a simple example of implement co-clustering on Word document matrix, changing rows, columns, and rows for finding submatrices in dyadic data matrix. And that NMTF co-class with based on Frobenius norm or equivalence distance by adding two regularization based on determinate R transpose and CC transpose for two parameter control row and column separately. Thank you very much. Goodbye.